I want to start off today's lesson with a little review of inverse functions. You don't have to write this part down on your notes. I'll tell you when to start that. So suppose we needed to find the inverse of f of x equals 2/3 x plus 4, which you should recognize as a linear function. Remember, we changed the f of x to y, just switched it out of function notation, and wrote y equals 2/3 x plus 4. Then the next step, or one of the ways to do this, was to switch your x and y coordinates. So we swapped x and y, and then you solve your equation for y. So to solve for y, I needed to get the y by itself, so I subtracted 4 from each side and got this without the red. Then I needed to undo multiplying by 2/3, so I multiplied by the reciprocal 3/2, putting parentheses here because that's important. And then I distributed 3/2 times x and 3/2 times the minus 4. So I got 3/2 x. The 2 cancels with the 4 and leaves a 2. 3 times 2 is 6. So that's how I got that. And then I just switched it back to function notation. So f inverse of x equals 3/2 x minus 6. So that's the inverse of f of x equals 2/3 x plus 4. Also recall, you don't have to write this part down yet either, that graphs of inverse functions are symmetric across the line y equals x. So here's my graph of the f of x equals 2/3 x plus 4, and in red I have my graph of the reciprocal of the inverse. And notice my dashed line, that's the line y equals x, and you can see that if I folded this on the dashed line, that the blue and the red would fold onto each other because it's symmetrical across that line. So those are things, important properties to remember about inverse functions, and we are going to use that idea as we explore the inverse of exponential functions. So this is the part that you would need to start writing down. So what I'm going to start by doing is we want to go with what we're familiar with, and we are going, this is section 7.3, we're only going to do the first part of it, logarithms and logarithmic functions. So we're going to graph y equals 2 to the x. So first I'm going to fill those values in. I'm going to start with 0. 2 to the 0 power is 1. Anything to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. 2 to the third power is 8. And remember that if you go with a negative exponent, 2 to the negative 1, it doesn't make it negative, it's a reciprocal. So remember, 2 to the negative 1, you flip it over, you get 1 over 2 to the first, so we have a half. And here you're going to flip it, so you'd have 1 over 2 squared, which is a fourth, 1 over 2 cubed, which is an eighth. So then negative 3, 1/8, negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8. So we can see what we already have come to know as this exponential curve. So there's my exponential function. So now let's take a look. Remember that one way to find the inverse that we just talked about is to switch the x and y coordinates. So we're going to do that here. So I'm going to switch all my x and y's. So I have 1/8, negative 3, 1/4, negative 2, 1/2, negative 1, 1, 0, 2, 1, 4, 2, and 8, 3. And I'm going to plot those. So 1/8, negative 3, 1/4, negative 2, 1/2, negative 1, 1, 0, 2, 1, 4, 2, and 8, 3. And I'm going to draw this one in. And this is my inverse. Now, what is that inverse? What do we call that function? That actually has a name, and the inverse, well, you can kind of guess probably if you look at the name of this section. This is a log function. So this graph is y equals log base 2 of x. The base is base 2 because the exponential base was 2. So those two are inverse functions. So let's talk domain and range and asymptotes with these. Going back to my exponential function, The domain is all real numbers, because we could pick anything for x. The range is y is greater than 0. And remember, we had an asymptote, which was the y-axis, so that was y equals 0. So what about for my log function? Well, remember we switched x and y. So when you switch x and y, we are switching our domain and range. So our domain is, our range was y is greater than 0 from the exponential. So that means our domain is x is greater than 0. Our range is swapped with what our domain was from the exponential. So it's all real numbers. Notice it keeps going down and it keeps going up. And our asymptote, we switch x and y. So instead of y equals 0, it's x equals 0, which means it's a vertical asymptote. Okay? So that's our information about what our log function looks like, including domain, range, asymptotes, stuff that you will need to know. But what we're going to focus on today is the representation of log functions. And one of the things, and you'll see here, I'm going to skip over some of this information. It's important because it gives us kind of the definition of a log function. But they tell you this: if log base 3 equals 27 equals y, then 3 to the y equals 27, and how to switch it around. But I'm going to tell you this: log base 2 of 8 equals 3, since 2 to the third power equals 8. And I want you to remember that. These are numbers, you know that 2 to the third power equals 8, because you know that. That's something you can kind of wrap your brain around. You know 2 times 2 times 2 is 8. So kind of how do you match those up? Log base 2 of 8 equals 3, since 2 to the third power equals 8. If you remember this as an example, then you'll know which way to switch things around. So the base of the log becomes the base of the exponent. And the 8 and the 3 swap places, just like we swapped x and y. So that's basically what happened. So then that's what this information is saying here. Log base b of x equals y, since, or they if and only if, which means it goes both ways. I'm going to change this b to the y equals x. Notice that my log base becomes my exponent base. My x and y swap places. So that's how you switch from exponential form to log form, or from log form to exponential form. So here we have an example, right? Log base 3 of 9 equals 2 in exponential form. So it's in log form right now. We need to switch it to exponential form. So identify the base. Well, it's 3. Swap these two numbers, so I get 3 squared equals 9, which of course you know is true. Right, log base 10 of 1 over 100 equals negative 2. Now this one looks a little more confusing, but just do what I said. Start with the base, which is 10. So I'm going to put a 10. Swap these two things, so it's going to be a negative 2 power equals 1 over 100. And remember what a negative exponent does? Reciprocal, so you square the 10 and flip it over, and you get 1 over 100. So you can see how that works. So go ahead and try this problem. So you can pause it and try it. Oh, you should know this one. So this is the one I told you to remember. 2 to the third power equals 8. So we get B. Go ahead and try this one. So pause it and try it. Okay, you should have gotten C. The base is 3. Negative 2 power equals 1/9. Okay, so not hard to switch from log form to exponential form. Sometimes we have to go the other way, exponential form to log form. So keep in mind this is the base. 5 is the base. So I'm going to write log base 5, and then I'm going to swap places of 125 equals 3. And there we have it. Not hard, you just got to know what to do. Part B, the base is 27. So log base 27 and switch places of 3 equals 1/3. Make sure that you, when you do this, that this is like a subscript, a base. And the 3 is kind of in the same height, really, as the log for the logarithm. So don't make it look like a power or anything like that. Go ahead and try this one. So you can pause the video and try it. So you should have got log base 3 of 81 equals 4, which is A. And now go ahead, pause it and try this. Okay, so we have log, the base is going to be 81. And then we flip these or swap them. And so that is D. Okay? Now, for one like this, you're asked to evaluate log base 3 of 243. And I'm going to write down a question, because when you read this, we don't think in logs, because that's unfamiliar to us. We're more likely to think in exponential functions. So this is the question you're going to ask yourself when you see this. 3 raised to what power is 243? So that's the question you want to ask yourself. 3 raised to what power is 243? And then you can try that on your calculator and see, you try different things, and you see you get 3 to the 5th power. So my answer would be 5. Log base 3 of 243 equals 5, because 3 to the 5th power equals 243. So this is the question you want to ask yourself when you're asked to evaluate a logarithm. Evaluate log base 10 of 1,000. So the question you ask, this is really supposed to be you try it, but I only did one example like that. So this is the question you're going to ask. 10 raised to what power is 1,000? So that's the question you're going to ask. So 10 raised to what power is 1,000? And then it would be 3. So that's the answer. Okay, so, and you don't have to write down the question. 10 raised to what power? You can write it like this. 10 raised to what power is 1,000? And then think about it. Use your calculator to figure out what the number is. So today's assignment is to complete page 472, numbers 1 through 7. And it's not graphing logs. They are just as easy as the ones I just did, where you just had to switch from log form to exponential form, or vice versa. Or you might have to evaluate a logarithm by asking yourself that question. 7 problems, not hard. Do them at the end of your notes. Upload those with your notes as a PDF. Thanks.